my name is Caruso. I'm a co-founder. Hello? Okay. My name is Caruso. I'm a co-founder of the Seattle Wireless Project and freenetworks.org, and I'm going to do a talk about community wireless networks. And basically, I just want to talk a lot about the political, social implications, how the telephone companies feel about it, and that type of stuff. I'm going to use the term free networks. It's kind of the same thing as a community wireless network. It's a term that we coined basically to represent the philosophical ideas and not be tied to any one particular technology, because the things that really fuel this movement are not specific to wireless. So if we were able to do this with other types of technology, if we were able to lay fiber throughout our cities on our own, we'd do the same thing that we're doing with wireless. But basically, right now what a free network is there's a couple of different types of free networks, but for the most part, it's a scenario where anyone can join the network, anyone can put up a node on the network. There's no barrier to entry. All that's required is that you provide the gear and the know-how to run your devices. And the free is kind of confusing. Some people think that it's free internet, and it's actually not. We're not necessarily focused on free internet. It's mostly free as in freedom. And as far as the people involved in the project, it's anything but free, because we spend a lot of time, a lot of money trying to figure out how to make this stuff work. So I kind of briefly talked about the different approaches. For a couple of the community wireless groups, their mission is free internet access, and as Adam had mentioned earlier, it's kind of like the philanthropy aspect of it. And then there's what people consider the isolationists, which is kind of like what Seattle Wireless falls into, where we don't even really care about the internet. We want to build a metropolitan area network that's self-sufficient, that doesn't rely on telco infrastructure at all. And so that means that we're like providing our own core services, DNS, and all that stuff. And we basically want to be able to exist without the internet. We don't have a problem with the internet, and we don't want the internet to go away, but we want to have a network that's sustainable and that doesn't have to go over telephone company lines. Basically, a lot of people want to know kind of why this is happening, and what are the reasons why this is starting to crop up in the past 2 years. And there's a couple of things that I've identified. One of them is that standards-based technology is available. If you wanted to build a community wireless network, say 3 years ago, you would have to choose from a technology that would lock you into one vendor. There were really no established standards, and so you'd have to go to one company, buy all the gear from them, and it was really expensive. Now cards are really cheap. You can buy a wireless network card. They're selling them in the vendor area for about $50. And there's a growing desire for connectivity everywhere. Everyone wants to be online all the time. And the hacker community and the techies that are involved with this kind of feel screwed over by ISPs. I mean, we all, when I first got my first home high bandwidth connection, I was really excited. And then I found out, well, I can't run any servers, or they're going to filter certain ports, and there's a lot of things I can't do. So I think a lot of people are kind of feeling screwed over by that. And so they kind of want some sort of relief from that technical oppression, if you want. And by building self-sufficient networks where the community is in control, you can do all of that stuff. And it's existed for a long time. The BBS community, FidoNet are all good examples of a very, very similar movement, very similar motivations. So basically, there are a lot of people that are not really very fond of the free networking movement, and the ISPs in general, like big ISPs like AT&T, and those guys, they don't like us, or they claim they don't like us because they think that we're a threat to their business model and that we're going to give away their bandwidth, which is actually not entirely the case. I mean, a lot of we understand that bandwidth costs money, and what we do in a lot of cases, and what they're actually doing in Portland, Oregon, is they're working with local ISPs, mom and pop ISPs that are willing to give them connections where they can share internet bandwidth, and in turn they actually get some useful information out of that, because now these ISPs can look at community wireless nodes and they can see how much traffic's going through their nodes, and it gives them data, and they know whether or not this is actually a threat to their business model, whereas companies like AT&T, they don't even want that data, which is kind of a shame, because I think if they actually saw the data and what was going on, they might actually change how they feel about it. Another other reason why the telcos, I think, are kind of upset is because 3G has not taken off. You know, all the people in this room probably understand the difference between the 3G network and 802.11b network, completely different things, but to the corporate user or to typical end users, they don't know the difference. All they know is that now they can walk around with their laptop, they can go to the airport, they can go wherever they want, and they can get on a network. Wireless ISPs are kind of concerned about it because this is a public band. Current technology that we're using operates in 2.4 gigahertz, which is completely unlicensed, which means that anyone can use it. We're in the same band as 2.4 gigahertz cordless phones, the X10 video cameras, and so we're really concerned because their business model relies on this unlicensed band, you know, which, I don't know, if you ask me, that's kind of a risky business model to have, but it's something that, you know, that has to be considered, and they have no more right to the band than we do. And also the FCC, this is kind of an interesting thing because like Pringles can antennas are really popular, all these parabolic dishes are really popular, but when it comes down to it, there's a lot of regulations about using antennas with 802.11b cards, and it is technically against FCC regulations to use a Pringles can antenna because the antennas do have to be certified with a specific card that you're using. So who likes us? Well, actually, this is kind of on the other side of it, I think a lot of the bigger ISPs that have been offering all-you-can-eat internet access for a long time, or for the past couple of years, actually do kind of like the fact that this movement is coming about because it gives a little bit, it takes away a little bit of the burn because, you know, they've been doing this all-you-can-eat internet access. They're starting to find out that, you know, they're not making money on it, and now this is kind of something that they can focus not necessarily their attention to, but they can say, look, you know, there are these people doing this. This is the reason why we're not making money, and it's kind of another excuse for them to go from this all-you-can-eat internet access model to value-added services, you know, where you have to pay if you want to use a VPN, or you want to, you know, you have to pay extra for all these additional things. And the media, of course, loves us because it's, you know, because of the controversy. Every single media person that I talk to, they want to know, you know, well, how, you know, does AT&T hate you? Do you guys get into fights on the phone? You know, all this crazy stuff. So, and there's a lot of confusion too. One of the most common questions that people want to ask is, you know, why would you do this for free? What, you know, why in the world would you want to do something like that? Venture capitalists, you know, I get calls from VCs probably about once a month wanting to know like what my secret plan is to make money. They think that, you know, somewhere stashed away after about 2 years I'm going to come up with some brilliant idea and I'm going to turn this thing into like, you know, a multi-million-dollar business, which is totally not the case. And they want to know who pays for it. They don't understand that, you know, people will do stuff on a volunteer basis. I mean, with Seattle Wireless, all of our nodes are owned by individual people. They pay for the equipment. They pay for, you know, they spend their own time. There's no real like centralized, you know, repository for funds or anything like that. So they don't understand why someone would go out and buy equipment, spend time to set up equipment when they don't have any, you know, perceived retribution. And it's also kind of confusing too because I don't think that the ISPs and telephone companies aren't really sure. They're like, well, you know, people are reaching bandwidth and we're potentially losing money, but at the same time, they're kind of confused. They don't know. This could potentially be a good thing for them. I mean, if we were to set up agreements with internet service providers and telephone companies, it could be a benefit to them, but there's really no clear understanding of what's going to happen. And privacy too. I think one of the big things about community wireless networks, especially with the model that we're using with Seattle Wireless, is that it can promote privacy with localized communications. If I'm communicating with my neighbors or people down the street from me, and I'm going, you know, over 3 wireless hops, well, I'm not going, you know, I'm not going. My packets aren't going to California and then coming back into Seattle because me and my friend are on 2 different ISPs. So if someone wants to, you know, inspect that traffic or sniff that traffic, they have to come, they have to be in that physical area, and it's not as easily to do remotely. And because it's decentralized, because each person owns their individual node, they can't go to an ISP and they can't say, look, you know, we want to put a tap on all the traffic coming from this person. There's no core aggregation points for them to come and inspect traffic. And also, you know, to get involved with this, you don't have to give us any private information. You don't have to worry about us selling, you know, your surfing habits and that type of stuff because it can be fairly anonymous. And so the community and independently owned infrastructure, it's a different way of thinking, and it's really confusing for a lot of people. They just don't understand. I mean, one of the things that I really like about it is that, when you look at right now the local loop infrastructure, you're basically paying, we're not renting phones anymore from the telephone companies, but it's still pretty close. In a scenario like this, if you wanted to get on a local loop, you just buy your gear, you install it, and you're on the network. Now you can make a voice over IP phone call to your neighbor or to someone across town, and you're not paying $30 a month to the telephone company. And that's actually the thing that's interesting, I think, about the local loop monopoly is that the internet service providers don't realize us sharing bandwidth or giving away bandwidth is not really a big threat to them. What's a big threat to them is the local loop monopoly, because that's something that, once that happens, then they're going to lose a ton of money. And so faster deployment of new technology, basically in an environment like this, in a kind of organic, ad hoc environment, it's a lot easier for us to deploy new technology, stuff like IPv6. We can do a lot of research and development work, and we can move a lot faster and be more flexible than a lot of major providers. And let's see, what do we got next here? Peer-to-peer. Okay, so this is another big thing too, and this goes back to the whole exchanging data with people in your local area. Right now, peer-to-peer, like file sharing and peer-to-peer communications, it's kind of a weird model because you have no idea where the person is, you have no idea how close they are to you. In a situation like this where you could have location-based apps because you know the location of all the physical devices, and a peer-to-peer file sharing application or any sort of peer-to-peer app could go out and it could find the most efficient route to your node. And why would you want to go get something from the internet when you can go get it from your next door neighbor at 11 megabits? And let's see. And so more on the peer-to-peer thing, I guess. The thing that I think is kind of interesting about this, not even from the wireless perspective, but I think that if the telephone companies would kind of look at the way they're structuring their business right now with a lot of this stuff like file sharing and whatnot, if they were to offer higher transit to all their customers, so say for instance me and my neighbor are both a customer of a particular ISP, I'm rate limited as soon as I leave the door. I don't get faster transit to my next door neighbors, and so something like a community wireless network promotes that, and I think it's sending a message to the internet service providers, because if they were to provide faster access to people in the same area as you, not only would it be better for the people that want to exchange data because they'd be getting faster rates, but they'd also be saving them money, because now instead of downloading your movie or your MP3s from someone across the country, you're getting it from someone that's on their local network. It's not going out their upstream connection. So basically the survival, what is it going to take for the wireless community, the free network movement to survive? Obviously strong local community relationships. That's really the Seattle Wireless, that's one of the core things, is our monthly meetings, our mailing lists. We have strong communication between everyone involved in the project. That's definitely really important to promote our survival. Pressure on vendors to release drivers and information for open source OSs. As this networking as the wireless networking technology is progressing, it's kind of funny, because now the cards are getting dumber and dumber, and they're going to put more and more of the stuff that's on these cards into software drivers, which means that the FCC is going to, your radio is going to be more software than anything, which means that the FCC is going to have to get involved with with hardware drivers and stuff, and they're probably not going to want to release a lot of that information, because then if they have all the hooks into this card, then you can pretty much do whatever you want if you know how to operate the card. So I think there's going to be, we've already seen it with 802.11a, where currently the 802.11a chipset that's been shipping, I don't know how long it's been, but it's probably been at least 6 months. There are no open source drivers for it. There's supposedly binary drivers that Atheros, the vendor, has been giving to customers, but there's no open source drivers, and that's because they have so much of the information in the driver, they're afraid of giving away trade secrets. So they need to understand that this, we need to put a lot of pressure on these guys to give us the information that we need. Being good RF citizens is also a really big deal. I mean, this is a public band. We're sharing it with everybody. So you want to work with your local wireless internet service providers. You want to make sure that you're not starting any wars with them and doing anything like that. You want to be good citizens. You want to make sure that you're not hooking up a 1-watt amp to an omnidirectional antenna. You want to try and use point-to-point links wherever possible, so that you're not increasing the amount of noise that's in your area. FCC compliance is a big one. This is what I was talking about earlier, with Pringles can antennas, with high gain antennas, basically, if this stuff ever takes off, and if we ever really progress, the first thing that they're going to do is they're going to crack down on wireless stations and whether or not they're compliant with FCC regulations. Currently, wireless ISPs, not necessarily hotspot providers like the guys in Starbucks, but out in the Midwest in a lot of areas, there are wireless internet service providers that are doing fixed point wireless. They're already starting to get inspected by the FCC. The FCC shows up at their door, and they want to see all the receipts for all the gear. They want to see all your serial numbers. They want to make sure that all the gear is certified to work together. If I go and I buy like a wireless card like this, and then I go to another vendor and say this is a Cisco card, and I go to Lucent and I buy a Lucent antenna and plug it into this card, I just violated FCC regulations because it's not certified. The antenna that I'm using is not certified with this device. So if we want this stuff to actually survive and continue, to progress, we have to be completely vigilant about making sure that all of our nodes and all of our stations are compliant with FCC regulations. Spreading the gospel, obviously, I guess, coming to conferences, evangelizing wireless networks, explaining to people, why localized communications are better. When I go and talk about this stuff to people that aren't very technical, they have a hard time understanding, the concept of, not worrying about internet access. These people don't even know, when they're at their company, they don't know that there's an intranet and an internet. They think that everything goes to the internet. So people really need to understand the value of a local network, a local high-speed network. And global collaboration is a big one. There's currently 182 wireless community groups that I know of, ranging from China to North America, Europe, South America, and we need to all work together, and we need to communicate. We try to do that right now with the freenetworks.org. It's kind of like an aggregation point for all the wireless communities, and that's really important because we all face a lot of the same technical problems. We all face a lot of the same political problems, and actually in some cases we face different political problems. Currently in France, if you wanted to build a community wireless network, you'd be breaking the law because you're not allowed to use stuff like 802.11b outside of your house. It's against the law. In England, up until about a couple of months ago, it was illegal for any two entities, like say I owned a business and you owned a business and we wanted to set up a wireless link to each other, that wasn't allowed. So, all that stuff is really important, that we all kind of get on the same page and share information with each other. And finally, how would someone start a community wireless group? I've talked to a lot of people here at DEF CON, and a lot of people are really frustrated because they live in areas where technology isn't very prominent, and they want to do the same thing. They want to start building wireless networks. And obviously, this is a no-brainer. You got to check to see if the group exists in your area. But go out and start a mailing list, start a web page. I think one of the things that's helped the Seattle Wireless Project a lot, and also the Personal Telco Project in Portland, is that our web page is wiki, which basically a wiki is a website where anybody can edit any page. And so anyone can go to the site, anyone can add information, anyone can update information, anyone can remove information, and it does diffs and it keeps backups, so if someone does go and vandalize the site, you can go back and you can restore it. But that has been really key in our success. I mean, the amount of information that is on the Seattle Wireless sites and the Personal Telco sites is incredible, and if we'd had to have like a team of webmasters or somebody maintaining all this information, it would never happen. So collaborative technologies like that are really important. And here's a bunch of links, freenetworks.org, Seattle Wireless, all that stuff. If you guys can get the presentation off of the CD, that's all on there. And I guess I was going to wrap it up here with just a couple of dumb pictures that I've collected in the past 2 years that I've been doing this, and kind of give you a little short story on each one. So this was actually one of the first Seattle wireless nodes to go up. It's an omnidirectional antenna that's on this wooden mast. It was fastened to the house with speaker wire, and so it's obviously not up anymore. So just mental note, speaker wire doesn't hold antennas up. This is a guy at one of the Seattle wireless meetings. This is actually a node he built that runs DOS. I think it was just DOS 6.2 with some userland program that does IP routing. So it's actually technically remotely unrootable because you can't actually interactively log into the box, but then again, you can't do any remote administration on it either. And this is the reason that I use BSD. This is This is from a Digital Divide conference that was put on by Microsoft in Seattle, and a bunch of guys from Seattle Wireless went down there because the local Linux users group was kind of demonstrating, because it was one of these things where, Microsoft is trying to help out third world countries with expensive software licenses, and so they went to demonstrate and give out free CDs, and so we went down there to kind of try and roust up some Linux guys to come and check out the Seattle Wireless project. I don't know, I just thought this is a funny picture, so put it up there. These are the enemy. They're Pringles cans, and we had a big meeting where we were showing everyone how to make Pringles cans just to try to get them involved with the project. And like I said, we don't condone using them. It's a bad idea. They're not bad. They're bad antennas, and they're illegal, so don't use them. And I always think, whenever I see this picture, I always think, if you ever seen the movie with Steve Martin, The Jerk, where he's getting shot at, and he turns around and looks at the oil cans, and he's like, he hates these cans. That's what I think of that. This is one of the core routers on the Seattle Wireless project. It belongs to Eric, who's around here somewhere. I don't know if he's here, but it's basically 3 RG1000 boards that were ripped out and put in a waterproof case, and they all netboot Linux, and we currently use static routes, so nothing fancy going on in there. The boards are like a 486, but they got an NFS and a TFTP server in the house, and then it runs power over Ethernet up to the roof and boots Linux on these things, and so there's actually 3 antennas up on the roof. And this is a funny picture. This is me and my friend Matt, and we were talking to these 2 guys from NTT, which is a big telephone company over in Asia. And the funny thing about this story is that, the telephone companies and big ISPs in the United States, they don't really like us, and they don't really have good things to say about us. But the telephone company in Japan calls us up and basically invites us out to lunch, brings Visio diagrams of this, 300-node hotspot network that they're rolling out in Japan, and basically asks us questions for an hour about what we think of their network structure, of their business model, all this stuff. So, it's just kind of an interesting contrast, because they love us. But this is my friend Casey standing next to an omnidirectional antenna hooked up to a 1-watt amp. I don't condone that either, but he's an amateur radio operator, so he can do stuff like that. And we think that's kind of the cause of his acne problem. We don't really know why. I think it's 1 watt at 2.4. This is Ben, one of our guys at the Seattle Wireless meeting, brandishing his antenna, and not meant to have any sexual innuendos there. This is a Yagi antenna that he was designing. And this is from the last wireless summit. Every year we have a wireless summit where we invite community networking groups from all over the country to in one location, and we basically try and hash out all the problems we have. This last one we had in Seattle, about 200 people showed up, and it was a good time, and that's about it. I don't know, if you guys have any questions, I could probably answer a couple of questions here, but we're running kind of behind schedule, so what I'd like to do is probably take like a couple of questions. Is that okay? And then if you guys want to talk to me some more, I'll head out to the bar, and we can talk out there. I'm sorry? There's no such thing as a 1-watt antenna. What? No, it was a 1-watt amplifier is what we were using. To be honest with you, I don't know a lot about amplifiers. I believe we were using a Teletronics amplifier. It was like $200 or something like that. But yeah, don't use amplifiers. They're not good. I'm sorry? Currently, we use a variety of APs. We don't have a standard on any one particular vendor. We use a lot of Lucent APs just because we got into a scenario where we actually did a group purchase and got a bunch of them for $60 a piece. But we're not really vendor specific. Yeah. How do you handle quality of service? We don't. That's a good question. Well, currently, it's one of those things, I think, where until we actually have people on the network, using the network consistently, like right now we've got 30 nodes, somewhere between around 30 nodes with 7 point-to-point links, and there's activity on the network, but there's not really enough to get stuff like that going. But currently we have no official plans for doing QoS. Yeah. Okay, the question was, do we have any formal policy about bandwidth heavy applications? And no, currently we don't. The way we kind of figured that this would end up working out is that if you've got a bunch of people that want to use high bandwidth applications, it's in their best interest to get with the people, the nodes that they're connecting to, and maybe put up additional links so that they can, get more bandwidth between them. We currently have really no formal organization whatsoever. It's just at such an infant stage that it's just not there. And yet, at some point in time, if it does really take off, then it's going to be like the internet. You're going to have organizations that do stuff, like Aaron takes care of IP addresses, and this group does that. That stuff will probably be required if it gets that big, but currently we don't have anything like that. Yeah. I'm sorry? To be honest with you, you mean brand-wise or vendor-wise? The question is, what equipment do most clients use to get on the network? Well, currently the structure of the network is that, outside of the point-to-point links, there are access points that people get onto. So for the most part, they're just using normal wireless cards. In our core network routers, we use Yagi antennas, parabolic antennas, and but as far as end user, they generally, unless they have a little mini extender antenna or something like that, it's just usually a card. The question is, how do we deal with IP addresses? And that's a good one, because we actually use non-routable address space specifically because of the organic growth of the network, and also for other reasons with IPv4 address space. We feel that it's better for, it allows us to move at our own pace, and it allows us to manage our own address space. We're actually setting up a RIPE database to manage the IP space for us. When we start to do more stuff with IPv6, we're going to try and start using routable addresses, but right now it's not a big deal because we're not really concerned about internet connectivity. If people want to get on the internet, then yeah, they're going to have to be NATed or go through a proxy server or something like that. The question is, what do we do about liability? And that's a good question too. And in the sense that we're not really focused on providing internet access, we're not really, the only liability is within the network. So if you have a 30-node network, then the liability is within those 30 nodes. I'm not, I guess right now the way it would work is that probably someone that I know will call me up and say, yeah, some dude was port scanning your box, So there currently isn't any liability issues. And obviously, if someone wants to provide internet access on one of their nodes, we suggest that they run a portal of some sort, like a catch and release, where when you get on the node, it gives you a splash page with an acceptable use policy, and do your basic stuff to whatever, filter port 25. I know it's kind of funny because there's you can do all of this stuff, you can block all these ports, but when it comes down to it, as long as there's connectivity going out to the internet, someone can always launch an attack from there. So, but yeah, basically forcing people getting on the network to see some sort of acceptable use policy and acknowledge it before they continue on. Where do I see myself in 2 years? Well, I know where I don't want to see myself in 2 years. That's a good question. I think in 2 years, one of the things that is really going to help our project take off is we've been talking to the city of Seattle about helping them with emergency communications, and I think that's going to help us a lot. Emergency communications is interesting because a lot of the emergency communications that they use right now for doing data transmissions is really low bandwidth. Such low bandwidth that even encrypting the data is it's just choking you. So I think that stuff like this is really going to help out a lot, because not only will they get not only will they be able to exchange way more data, but they'll also be able to take better security precautions too. Yes. You're gonna have to shout really loud. Can I get a repeater in between us? Could someone relay what he's saying to me? I can't hear him. I can't hear you. Could someone relay what he's saying? I can't hear him. What about it? Oh, inner city Okay, that's, well, we currently don't have it, and I mean, we would have to, if we wanted inter-city connection, at this point in time, we would have to have like some sort of, we'd have to do like an IP tunnel over the internet. I mean, if there was enough, if there was enough saturation of this movement, I mean, it would be, potentially have like a mesh over the entire country. However, the technology that we're currently using won't scale to that point. So right now, we don't have any inter-city links, and we don't have any VPNs or anything between the different wireless communities. That's a good question. It depends on the question. The question is how large can we grow before we kind of reach the scalable limits of 802.11b, and we can't really. I would say that we could probably not have more than maybe like 10 or 15 core backbone routers, because I mean you only get 11 megabits, and it's not actually, you're not even getting 11 megabits. Usable throughput is about 5 or 6, so that's really, I think, like one of the limiting factors. I couldn't give you any numbers. I don't know. All right, well, I'm going to wrap it up now and get on to the next presentation, and I'm going to head out to the bar if anyone has any more questions for me. Thanks, and I'll talk to you later.